In this lesson, we want to learn how to solve linear and quadratic equations simultaneously. So we should be talking about simultaneous linear and quadratic equation. So in this particular video, we're paying attention on solving simultaneous linear equations. That is solving two linear equations at the same time. That's what we should be looking at in this particular video. But before then, I would like to make a little distinction between a linear equation and a quadratic equation. So recall that a linear equation at this level should be defined as this is mx plus c. So it is an equation of this form such that m is the slope, x is the variable, or rather x is the independent variable, c is constant, and y is the dependent variable. So at this level we allow it to be linear, but in advanced level this is actually an affine. Then the linear equation at that point should have no c's, should be a line passing through the origin. But now we'll allow it to be a linear equation. So of this one, so an example is this. One can have y to be maybe 3x plus 2. It can also appear in different form. For instance, I can have 3x plus 2. This is also a linear equation. But one thing you should also watch out for in linear equations is that the independent variable, that is x, also has the index 1. So you know that this is the same as x raised to power 1. So this is actually what makes it linear. So the index is 1. So these are the things you watch out. So this is the general form. Then I have some particular examples of particular cases here. This is what we refer as being linear. Then quadratic equation, we are very familiar with a quadratic equation having of this form: ax plus bx plus c. This could also be equals to y. But when y is 0, we are looking at the root of that quadratic equation. So this is actually a function, which is a quadratic nature. So this is an example of a general form of a quadratic equation. And what you watch out is that the index of the independent variable, the highest power of the independent variable is 2. So you look at a function of this nature. Maybe you look at 3x squared plus 2x plus 3. This is a quadratic equation. It can also appear in this form. Maybe I can look at, let's say, 3x squared plus 2x plus 3 equals to 0. This is when I'm interested in looking for the root of this quadratic equation. So these are the difference between a linear and quadratic equation. So after studying simultaneous linear equations, we're going to look at the combination of this linear equation and quadratic equation, how to solve them. So that's actually what we are looking at. But for now, we'll be looking at linear equations only, how to solve them simultaneously. And we'll be kicking off with the example on the board. So actually, we are to solve these equations. We have them in fractions. So we have 1 over 3x plus 1 over 4y. This is equals to 5. Maybe we regard them as equation 1. Then the other one started with 1 over 5y. But instead of writing 1 over 5y, we want x and x to be here, y and y to be here. So we want that alignment. So in order to achieve that, we start from here. We start writing minus 1 over 4x. So here I have minus 1 over 4x. Then before I will now write y, which is now 1 over 5y. This is equals to minus 13 over 20. Maybe we'll call this equation 2. So this is actually what we want to solve. We want to solve them simultaneously. So you agree with me that this is linear. This is linear. For instance, you are looking at the index here. This is 1. This has degree 1 as the highest power there. This one also has degree 1 as the highest power there. So this is a linear equation which we need to solve. So how do we tackle this? You can either use elimination method or substitution method, but the choice is yours. There are two things you can do. First, you can decide to clear the fractions. So in each of the equations, we might decide to remove these fractions. And you know the LCM of 3 and 4 is 12. So you can use 12 to multiply through to remove the fraction. Then when we come to the second equation, you observe you have 4 and 5. And the LCM gives us 20. So you can also multiply by 20 to remove the fraction. So that is another way you can go. Then secondly, if you decide not to, you can do the elimination directly. But let's clear the fraction so that it is easy for us to work with. So in equation 1, you multiply by 12. Then in equation 2, you multiply by the LCM, which is 20. So this helps us to remove the fraction. So in equation 1, where you're multiplying by 12, if you multiply by 12, you have 12 times 1 over 3x plus 12 times 1 over 4y, then is equals to 12 times 5. In the second equation, you're multiplying by 20. So you have 20 times minus 1 over 4x, then plus 20 times 1 over 5y, then is equals to 20 times minus 13 over 20. So now we are going to have another new set of equations. So what are we going to have? So when you are multiplying for here, so let's just rule it out so that we have a new equations here. So here what happens? Here you have 3 divided 12 will give us 4. Here 4 times 1 is 4. That is 4 times 1 times x. So in equation this now gives us 4x. Then here you have 4 divided 12 give us 3. Then 3 times 1 is 1 times y. That gives us 3y. Then here you have 12 times 5. That will give us 60. So here we have new equation. Maybe we call it 3. Then we go the other side or the other way. You have here 4 divided 20 gives us 5. 5 times minus 1 is minus 5. Minus 5 times x gives you minus 5x. Then here you have 5 divided 20 is 4. 4 times 1 is 4 times y. 4y. And this here you have that 20 will cancel out 20. So you're left with minus 13. So this gives us minus 13. This is equation 4. Now equation 3 and 4 has come back to what we know how to handle. So I think we should be comfortable working with this now than working in fraction. So this is actually what we have, and we apply the method of elimination to go through this. So we are looking at equation 3 and 4 now. So now to solve this, now we use method of elimination because we know that each of the coefficients, that is none of these coefficients, this 4 minus 5, none of them is 1. So the safe method to use is elimination method. So we decide which one to eliminate. The choice is yours. If we want to eliminate x, suppose we want to eliminate s, we ensure that what we have here and what we have here coincides. So if you multiply the first equation by 5, here becomes 20. If you multiply the second equation by 4, here becomes 20. So the coefficient will coincide. So that's what we are going to have if we eliminate x. So now we are choosing to eliminate x. So we are going to multiply equation 3 by 5. Then multiply equation 4 by 4. So now multiplying equation 3 by 5 gives us 20x here. That is 5 times 4x is 20x. Then 5 times 3y gives us 15y. And 5 times 60 gives us 300. Then the second equation, we are multiplying by 4. So 4 times minus 5x gives us minus 20x. Then 5 times 4y gives us 20y. And here 4 times minus 13 will give us minus 52. Okay, so that's what we have. Then you agree with me to eliminate this x. Just do an addition here. That is 20 plus minus x. So that will eliminate. So if you do that, you see what we have. So here, so let's see. Here, remember, we are multiplying here the second equation by 4. So remember, we're multiplying here by 4. So 4 times minus 5s gives us minus 20s, which is correct. Then this 4 times 4y will give us 16y, not 20y. Okay, so we have to correct that. Since we have corrected that, so this is now what we have. So here is 20 minus 20 here. So we have minus 20x here. Okay, so now what do we have when we add is 20s minus x. So that one is gone. Then here we have 15y plus 16y. That will give us 31y. Then here 300 minus 52. We still have it as 248. So one we now divide. So we now have 31y is equals to 248. Now to get one of the values, which is y, divide here by 31, divide here by 31, so that here 31 divides this, you're left with y. So y is equals to. So now what happens is now 31 divides 248. So that will give us 8. So we have gotten y to be equals to 8. You remember that the unknown, what you are looking for is the unknown. You are looking, your interest is on the x and the y. That's what you are looking for. So we have gotten y. So we need to get x. So how do we get x? You put y in any of the equations. So we are going to substitute y equals to 8, either in equation 3 or equation 4, to get the value of x. So we now say substitute that y, which is equals to 8, in equation, any of equation will work. So supposing I say equation 3 is okay. So I can say equation 3. If you substitute in equation 3, what do we have there? We have 4x plus 3y. But instead of writing y, you write 8. Remember that 3y is the same as 3 times y. So this will be 3 times 8. And it still equals to 60. So from this, the only unknown you have there is x. So you can solve for your x. So 4x, 3 times 8 gives us 24. Equals to 60. You collect like terms. So we now have 4x is equals to 60 minus 24. So we have that 4x now is equals to 60 minus 24 will give us 36. So we divide both sides by 4 to get x. So this will give us x. Then 36 divided by 4 gives us 9. So what we have done now is that therefore that our x is equals to 9 and the y, remember that our y is still equals to 8. So our y is equals to 8. So this is actually the solution to that simultaneous equation. But before we round up, it is important to verify this. So let us go back to our original equation and see if we put x equals to 9 and y equals to 8 on the left hand side, whether it will give us what we have in the on the right hand side. So we check that. So you recall, this is the original equation we have. That equation 1 and 2 is our original equation. So you remember that we have x to be 9 and y to be 8. So this is the original thing we got. So we move to the left hand side and we check that for both equations. So on the left hand side for the equation 1, you have 1 over 3. 1 over 3x is the same as saying 1 over 3 times x. So this is 1 over 3 times x. What is x? X is 9. Then plus 1 over 4 times y. That 1 over 4y is the same thing as 1 over 4 times y. What is our y? Our y is 8. So now let's see. So what we want to check, will this give us 5 that is on the right hand side? Then after that we go to equation 2 and check the same thing. So let's do that. So here 3 divides 9 gives us 3. 4 divides 8 gives us 2. So what we now have here is now 3 on here. Then remember we have plus. Then plus what we have the other is 2, which is equals to 5. And this corresponds to what we have on the right hand side. So this is okay. Then we check also whether it will also work for equation 2. So equation 2, we look at the left hand side of equation 2. You have minus 1 over 4x, which is the same thing as times x. What is x? X is 9 plus 1 over 5 times y. What is y? Y is 8. So let's see. if this will give us minus 13 over 20, what we have on the right hand side. So now let's see what we have. So here we have, that is minus 1 over 4 times 9 is sent as minus 9 over 4. Then plus 1 over 5 times 8 is the same thing as 8 over 5. Then the LCM, so this gives us, the LCM is 20. So 4 divided 20 is 5. 5 times minus 9 gives us minus 45. And 5 divided 20 is 4. 4 times 8 is 32. So what do we have? This gives us minus 45. This is just the same as saying 32 minus 45. Remember, it's always advisable to write the positive value before the negative value. So 32 minus 45 over 20. And you agree with me that this will give us a minus 13 over 20, which is the same thing as what we have on the right hand side. So actually, this verifies that x equals to 9 and y equals to 8 actually satisfy this equation. And that's what we have.